Okay, in this video we're going to be talking about the Unit 2 Quiz 2 review, so hopefully you are following along as I'm going through this. So let's go ahead and get started. First off, we have a Venn diagram, and so the Venn diagram, there's a couple things that they pretty much tell us, and there's a few things that we don't. All right, so first off, this, these four numbers will all add up to 300, okay? So in here, let's see, what information they tell us. All right, they say that 100 people voted for both. But notice it says 150 voted yes. So 150 is actually going to be on the outside, and then no is going to be, let's see what else, it's going to be 160. All right, so let's see, let me highlight here. If you notice, the 150 represents 150 people that are going to be in the yes circle. All right, there's 100 of the 150 in the both section, which means there's going to be 50 people that are in the yes only section. Now the same concept works for the no. So the no is 160, but 100 of that 160 is in the both section. So that means the remaining part of 60 will be in the no only. Now at this point in time, let me take this highlighter away. At this point in time, once you get to here, it's 50, 160. I'm just going to add this up and subtract it from 300 because all these four highlighted numbers will add up to 300. So when I do the math, it ends up being 90 people. All right. What is the percentage of people that voted yes only? Well, let's see. Yes only ended up being 50. So 50 divided by the total, which is 300, that'll give me a percentage rounded to 17%. What is the percentage of people that voted for yes and no? That's 100. That's the shared section. 100 divided by 300, that gives me a rounded 33%. The last one, or I'm sorry, question, I guess number 6, I didn't number this accurately. 2 fair dice are rolled. What is the probability that the sum of the 2 dice is 7? Well, this is a picture that I'm probably not going to give you, but I don't even know if I'm going to give a question regarding dice or not. I highlighted everything that adds up to 7. So what we have, and I showed this to you on Monday, all these are the possibilities that 2 dice can be rolled. I'm only focusing on what has the sum of 7. And if you can see here, there's 6 of them. So 6 possibilities out of a grand total of 36 is going to be what I'm looking for. So 6 possibilities out of 36, that's going to be a rounded 17%. Moving on. For an AMDM assignment, John created an area model and places values for each section, finished the area model, and answered the following questions. So John went ahead and put his values on here. We're going to be working off of his stuff. So it says that the entire side is 15, which means everything is going to be 5. Every row is going to be 5 because 5 times 3 is 15. Notice how this is, let's see, color here. Notice how this is 12, which means these little yes no's will be 6. Okay. This also will be 6. This will be 6. Now notice that all these really little yes no's are half of 6, which means this will be 3, 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 so on and so forth. Okay. Now that I have my width and height of each of these rectangles, I'm just going to simply multiply to get my area, and I'm just going to type in the areas here. So the area of this one would be 12 times 5, which is 60. The area of this one is 60. The area of this is 30. This is 30. This is 30. This is 30, because it's 6 times 5. Now what's nice about all these is that they're all the exact same. So this would be an area of 15, 15, 15, 15, 15, 15, 15, and 15. All right, so those are all my areas. And then what is the total area of the model? Well, the entire width is 24. The entire height is 15. So, or you can simply just add up all these individual ones. If I add up 60, 60, 30, 30, 30, 15, if I add all that stuff up, I end up with a model area of 360. So what is the probability of yes? Well, let's see. I'm just going to add up all my yes things here. So yes, see, that's a yes, that's one, that's a yes, 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 that's a yes. I'm going to add all those highlighted portions up. So when I do that, it adds up to 180. When I want to divide that by the total, which is 360, which is 50%. Now, if 500 people voted, how many people would vote no? Well, again, if 50% voted yes, then 50% will vote no. So 50%, and I'm just going to times that by the number of people, which is 500, which gives me 250 people. All right, the next question. There are 30 markers in a box, 6 blue, red, 7 red, 8 orange, and 9 pink. What's the probability of choosing a blue or a pink? So probability of choosing a blue or a pink. Let's say blue. Let's say we have 6 blues. We're going to add them to 9 pinks. We're going to get 15, and then we're going to divide that by 30, which gives us a 50% chance. What is the probability of not choosing an orange? There's 8 oranges, so that means there are 22 that are in the box that are not orange. So when we do the math, we end up with, when we reduce, it becomes 11/15, which when we do a percentage, I think it rounds to 37%. All right, our last question, what is the probability of choosing a red and then a blue without replacement? So if I was to pick a red, that would be 7 out of 30, okay? But then my next fraction would be a blue, which there's 6 blue, but then there's 29 markers, because when I pulled that red marker, I never brought it back. So that means there's only 29 in the box. So I'm going to multiply these two fractions together, because that's what I do when I do multiple events. And when I do that, I get 42 out of 870, which reduces the bell, which reduces to 7. Let's see, which reduces to 7 over 145. And then if we were going to convert that to a percentage, that would be rounded 5%. Okay. All right, the tree diagram here. If you remember anything about tree diagrams, every time that the tree branches out, that equals 100%. So when I start filling some of this stuff out, a lot of this is pretty simple because I already know what one branch is. So the first branch, see that 0.28? It will be 0.72 because those two things add up to 100. This right here is 0.63, which is going to be 0.37. Now, let's start filling in some of the first branch here. Now, hopefully you remember, and that is, if I was to take this branch, and if I was to take this branch, I would multiply these two together, which gives us this right here. Okay? So in order to work backwards, because remember, when you move in this direction, you are multiplying, but if you have to work backwards, you're going to divide. So I'm going to divide off to the side here. I'm going to take 0.0703. I'm going to divide that by 0.37. And when I do that, I'm going to get this number right here. So I end up getting 0.19. So this right here would be 0.19. All right. So I'm going to clean this up a little bit. Now to get E, which is right here, again, I'm going to take this branch, which is now 0.19, and I'm going to times it by this branch here, which is 0.63. That'll give me the answer to E. So the answer to E ends up being 0.1197. Now, up here, I have this number here. And in order to get that number, I have to multiply this branch by this branch. Well, again, I don't know what this branch is. But what I do know is what one of them is, so I'm just going to divide. So again, off to the side here, there's 0.0532. I'm going to divide that by 0.28. So when I do the math, it ends up getting, let's see, oh, another 0.19. Okay. So that ends up being 0.19. Now let me go ahead and clean this up again. So I don't want to make too much of a mess here. All right. Now, if you remember, these three branches will add up to 100%. So I'll just add those two, and then I'll subtract from 100%, or in this case, it'll just be 1. So that'll be 0.62. All right. Now, in order to get E, I should have did this a couple seconds ago. A times E gives me this number here. So 0.19 times 0.72, that gives me a fraction, no, not a fraction, a number of 1368. All right, now the last one we're going to do, again, let me clean this up, is going to be this number right here where my mouse is. I'm going to take 0.62, and I know I multiply it by whatever that is, and I get this number here. So I'm going to work backwards. So I'm going to subtract off to the side. Let's see, it's going to be 0.31, 00 if you really wanted to. And I'm going to divide that by 0.62. And when I do that, I end up getting 0.5. So if that's going to be 0.5, this down here is going to be 0.5 as well. There you go. Let's keep going. All right, you are in charge of ordering lunch. Now, the difference between this question and what we've been working with, throughout this week, is I went ahead and just said, hey, listen, here's the area model. There's the Venn diagram. So you have to do a couple things off to the side here. 70% wants pizza. So I'm going to go up to the pizza. I'm going to draw a straight line across. And then I'm also going to highlight. So I'm going to make yellow be the pizza. All this is pizza. I'm just kind of filling in here, going a little crazy, but going. All right, good. Next, 60% wants a hamburger. I'm going to use green, but first I've got to draw the line first. 60 would be right here, going up. There it is. So I'm going to use my green highlighter that represents pizza. Notice that we're getting a mixture here going. All right. So time to start labeling. This right here will be my both section. This right here will be my hamburger only, my HO. This right here is going to be neither because there's nothing in here. And then lastly, this will be yellow only, so that's pizza only. All right. Let's put some dimensions on here. So the base of my both section, let's see, that ends up being 60. My pizza ends up being 40, because 60 to 100 is 40. My height on the both ends up being 70. My hamburger only ends up being 30. My hamburger only base is 60. The neither is going to be 40. This ends up being right here. Let's see, that ends up being 30. And this one ends up being 70. All right, so let's find some areas. So I'm going to multiply base times the height, and that gives me 1,800 for my hamburger only. My both ends up being 4,200. My neither ends up being 1,200. And then lastly, my pizza only ends up being 2,800. All right, now this is where you're going to have to do a little bit of work off to the side. And so it says fill out the Venn diagram for the number of people. Okay, now both. I'll probably do this maybe 1 or 2 times and you get the gist of it. So my both area is 4,200. All right, so off to the side, I'm going to say, okay, let me get the percentage. All right, so 4,200 divided by 10,000, that gives me 42%. So I know that there's going to be 42% of whoever I'm asking. Who am I asking anyway? Oh, seniors. I know that there's 42% of my 500 seniors that want both. All right. So Again, off to the side, I'm going to do 0.42 times that by 500. And when I do that, I get 210. So the number of people I have in here is 210. Okay. Now we'll just do, let's just do neither. That's an easy one. Neither, that's 1200 right here. So again, off to the side, I'm going to have to convert that to a percentage. I'm going to do 1200 divided by 10,000, which gives me 12%. All right, so what was that? Neither. All right, so neither ends up being 12%. We'll put this down here. But again, 12% of 500. All right, so I'm going to say off to the side here, let's see, 12%, which is 0.12. I'm going to times it by 500. I do the math, that ends up with 60. So my answer ends up being 60. All right, so you're going to do that for the same thing for the pizza only as well as the hamburger only. So the pizza only ended up being, let's see, pizza only ended up being 28%, which 28% of 500 was 140 students. And the hamburger only ended up being 18%, which 18% times 500 is 90 students. All right. Now remember, as a self-check, remember that this number, this number, this number, and this number will all add up to 500 because that's how many is in the problem. So what is the probability of someone ordering both? Well, we kind of already solved for it. 42%. That's it. All right, next one, we have a whole big old tree here, and we're going to have to answer some questions regarding the tree. So let me zoom out just so we can all put this on the same page. All right, that kind of works. All right, so how many outcomes are there for Dave? Now, you can go through the tree, or you can just look at the tail end. All right, and what I mean by that is the final branches. 1 branch, 2 branch, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There's 12 final branches. There's going to be 12 total outcomes. Now, what is the probability that Dave will choose a lunch with fries? All right. Now, notice over here, and we're going to be scrolling back and forth a little bit, so forgive me for that. Notice all these final branches here. It's a choice between fries and chips. So fries and chips, that's a 50% chance. So what is probability? Well, 1 fry out of 2 options, which gives me 50%. Now, what is the probability that Dave will have either a burger or a bowl of soup? Again, a lot of information. You may not need it all. So let me kind of do all this mess. All right, so all we're looking for is a burger or a bowl of soup. Well, the burger and bowl of soup is all this stuff that's right here. He has 3 options, sandwich, burger, soup. He wants a burger or a soup, so that's, 1, that's 2 options out of 3. So 2 divided by 3, which gives you rounded 67%. And then lastly, question 18, what's the probability of a burger, soda, and fries? Well, if that looks like we're going to use the entire thing, let's see, the burger. Actually, I think I totally screwed up. And the reason I screwed up is I didn't even see these numbers on here. So you're probably yelling at the screen. Sorry. Now, what is the probability that Dave will choose lunch with fries? Going back to 16. That was right. Okay, 50-50. Okay. What is the probability that Dave will have either a burger or a bowl of soup? All right, so I apologize. Sorry. You're probably talking to me right now saying I screwed up. A burger is a 55% chance. A soup is a 15% chance. All right, I totally forgot about these numbers on here. Going way too fast. All right, so 55%, 15%. I'm going to add those 2 percentages together because this particular tree actually gives us the likelihood of something happening. So it would be 55% plus 15%, which gives me 70% chance of something happening. Excuse me. All right, so what is the probability of a burger? All right, so let me highlight. All right, so the probability of a burger, he's going to get a soda, which is 75% chance, and then fries. which is 50%. So these three branches, I'm multiplying these together, so 55.75 times 55. So 55 times 75.75 times 0.50. So when I do the math, I get, it's going to be a rounded 21% chance. It's a rounded 21% chance. All right. Okay, create an area model of following information. Okay, we've already done several of these in class, so this should be relatively simple. All right, so when you walk in, you have 1, 2, 3 choices. So I'm going to divide this up into sections of 3. Remember to make sure that you are trying to divide it up evenly. Now, luckily, I can do this and kind of get accurate. All right, so this right here is the upper path. This right here is the middle path, and this right here is the lower path. Okay. So, that's not what I wanted. All right, so what I'm going to do is, because of the fact that we've done this for so long, I'm not going to scratch out anything. We're just going to work on it together. All right, so if I start walking, boom, if you notice, there's a fork in the road. Now, this fork actually forks 3 ways. All right, we never dealt with that before. Well, we actually have. The worksheet yesterday had it. So I'm going to divide up my row 3 ways. And again, try to make it as accurate as possible. I'm just eyeballing this. That looks fairly good. Okay. So of these 3 ways, one of them ends up with a smiley face, which I'm just going to say, all right, let's put S. Smiley face, and the other 2 is nothing. In fact, I'm not even going to put anything on there. Now, the next one, let's see, we're walking, boom. Here's our very first fork in the road for this one here. And so that's going to cut everything in half. So I'm going to try to half this the best I can. That looks good. One of them ends in the smiley face, one of them doesn't. So I'm just going to put this as my smiley. All right. Now, the next one, I think the third one's going to be a little more involved. Not too much, though. All right. So I'm walking on the third path. Oh, there's my first fork. There we go. So I am going to walk on the second path again. Oh, there's another fork. So got a half my half over here. That's bad. That's actually a little off. There you go. Now, one of these paths go to a smiley face. The other one does not. So I'm going to go ahead and label accordingly. Just going to put Mr. Smiley right there. All right. Now, let's say if I was to stay on the 4th path, or the last path, sorry. All right. So if I was to stay walking, got myself a fork. So I'm going to try to half this as best I can. That works good. One of them ends in a smiley. The other one does not. So I'm going just to label the smiley. I'm just going to put that right there. All right. Now from here, I'm going to throw some numbers on here. I like to do the 12-2 situation. So we're going to say that's 2, that's 2, that's 2. And the entire bottom from here all the way over is going to be 12. So if that's going to be 12, then that means this guy right here is going to be 3. This 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 right here will be a base of 6. This right here is a base of 6. Now, this is where it kind of gets a little confusing because 12 has been divided 3 ways. So that means it's going to be 4. This is going to be 4, and this right here is going to be 4. All right. So when I start filling out my area, That is an area of 8. That's an area of 8. That's an area of 8. This is an area of 12. This is an area of 12. This is an area of 6. Area of 6. Area of 6. Area of 6. All right, so what is the probability of getting a smiley face? All right, let me go ahead and highlight just because I can, and it shows off a little bit. So there's my smiley mark. There's my smiley. Let's see, there's a smiley there. And lastly, there's a smiley there. Not there. All right. So when I do the math, when I add everything up, the probability of a smiley, when I added all those pieces up, I ended up getting 40. And I divided that by the total, which is 72, which gives me, I believe it's a rounded 56%. Now, if 25 people walk through the path, how many people would end up with a smiley face? Well, we just answered that. That was 56%. And then I'm going to times that by 2,500, which gives me 1,400 people. There you go. How easy it is. Okay, now we're going to start some basic review here. So we're dealing with the fan cost index. So if you remember the fan cost index, that is the family of 4. So we're dealing with a family of 4. So 4 tickets need to be purchased. Let me move that up so you can see it. 4 tickets need to be purchased. 4 Cokes need to be purchased. 2 beers need to be purchased. 4 hot dogs. 1 parking permit. 2 programs. And lastly, 2 ball caps, and that is going to equal, let me put the equal sign there, there. All right, so it'll be 4x plus 24, because I'm already multiplying here, plus 10 plus 16 plus 20 plus 10 plus 32 is equal to 292. When you combine like terms, you are going to get, let's see, that ends up being 4x plus, let's see, 24 plus 10 plus 16 plus 112. 112 is equal to 292. You're going to subtract 112, and when you do that, you are going to get 4x is equal to 100 and, I want to say 180. Yeah, I think it's 180. Yep, it's 180. And then when you divide by 4, you get 1, excuse me, 1 ticket being 45. And then lastly, if 1,732 families attended the game, so $292 is how much money is coming in per one family, and we're going to times that by 1732, which gives you an overall amount of $505,744. So that's how much is coming in into the game. All right, the UPC. All right, we've talked about this at length. So starting with the first numbers and skipping every other one, I'm going to add them and then I'm going to times them by 3. So I'm going to take it and I'm multiply by 3. So that gives me 66. And then my next step is all the ones that I skipped, I'm going to add up. That gives me 25. And my next step, I just add 66 and 25 to get 91. Now, remember, this number has to end in a 0. It does not. It ends in 91. So you think to yourself, okay, I'm sitting at a 91. Let's see if I can write this. So I'm sitting at a 91. I can either minus 1 to make the total 90, or I can add 9 to make this 100. Which one makes the most sense? Well, if I subtract 9, or I subtract 1 from 9, I get 8. If I add 9, I get 18. So what is the most logical check digit? It's going to be 8. So 8 is going to be my check digit because it's a single positive number. All right, credit cards, very similar to the UBCs. Starting with the first number, skipping remember, you take all those numbers and times it by 2, and when you do, you get 46. Now, also remember the credit card has the infamous 5 through 9. We're just going to let that ring because I do not want to pause the video. So the 5 through 9, let's see. The 5 through 9, yep, that's 1. Yep, that's 2. Nope, 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 nope. 3 and 4. There's 4 of them. 4. The next step is all the ones that you skipped, you add them up. You get 35. When the credit card procedure, you get 85 because you're adding everything beyond. So I added these 3 numbers here. Okay, so the 85 is obviously not something we can do. So let's see, how did I do this on the last one? I'm gonna keep it consistent. All right, sorry, I'm kind of talking to myself. I guess I should have shut that down. All right, so we're sitting at an 85. So 85, I either can add 5 to it to get a total of 90, or I can subtract 5 from it to get a total of 80. Well, let's see what makes most sense. If I take 9, and let's see if I can write it. I'm going to have to do a different color here. If I add 5 to 9, that's a plus 5, I would get 14. Well, right then and there, double digit, you know that's not going to work. If I subtract 5, I end up with 4. So which is more possible, the 4 or the 14? The answer, the check digit, should be 4. All right. So the check digit should have been 4, not 9. All right, lastly, what is going to be John's grade? He wants to make an 80 in the class. All right, so first thing I have to do is I need to average everything in this chart here. I want to add everything up and then divide by 4. And I'm going to times it by 0.40, which gives you a clean 31. The midterm is a 76, times it by 0.2, which is 20%, which is 15.2. All right, now remember the relationship, and that is the grade he wants minus the raw score gives you a number, and then you're going to divide that number by the final exam percentage, which is, in this case, 0.40. All right, so the work I'll just do down here. The grade he wants is going to be an 80, because he wants to have an 80 in the class. I'm going to subtract the 31 and the 15.2, and I get an answer of 33.8, and then I divide that by 0.40. The grade he's got to get on the final exam to make an 80 in the class is a rounded 85. All right, that's everything. Long video. Hopefully you understood it all. Let me know if you have any questions. Thank you.